Mr. Beak's math class. Mr. Beak's math class. Yeah! Woo!
All right, ladies and gentlemen, how we doing today? Today we are going to be talking about 2.5, the second half, which is solving OR inequalities. All right, so hopefully by the end of today you can say that you can do that. And if your mom asks you, hey, what did you learn today in school? You can say, well, Mom, I learned standard 9.2.2.1. And that will make you look really smart. All right, so hopefully we feel comfortable with the first half, which is the AND problems, which is, hey, if you have a small number in between, or the x is in between the small number and the big number, right? Those are the AND ones that we reviewed before. Today now, we're not learning the AND, so forget about those. Now we're going to be doing problems that say OR. For example, I could say to my 3-year-old daughter, hey, Ellie, after supper for dessert, you can have ice cream or chocolate. You can have one or the other. You can't have both, okay? So as a quick refresher, for graphing these inequalities, if you just had something like that, what you would do is you would just put the important number right in the center. You do one more and one less like that. We'd have to remember how we have our circles, and we have these ones are open circles, and less than or equal to, greater than or equal to would be closed circles, right? So this guy right here, that's going to be one of those guys right there, which is an open circle right at 4. And if we have the x on the left-hand side, which we do in this case, it's going to follow kind of that arrow pointing. So that one's pointing that way, so that's the way we're going to shade there. See how they're pointing the same way? And so that would be my answer for that first one, right? Let's say that I had to graph number 2, and then we'll call it good. This one's very, very similar. We're going to put our one important number right in the middle. In this case, it's -3. One more, one less. And I erased my key, but this one has the or equal to, so that means it's a closed circle. And x happens to also be on the left, so that means it's going to follow that same way of the arrow, which is x is less than 3, that would be to the left. Less than to the left. Okay? So real quick warm up, I'm going to skip those other ones for the sake of time and keeping these videos short. So today we're going to learn how to solve OR. Do you see the word AND? Nope, I see the word OR, so that's how we know we're using those ones. Now, if you have notes or if you have a sheet of paper, I would copy this super important red main idea down. It says x is smaller than the small number, or x is bigger than the big number. That's going to be our format and our kind of formula to follow for every one of these videos, okay? It's called a compound inequality because compound just means you got two. We got that one and we got that one, okay? The other type of compound is the AND that we looked at, all right? So let's look at this example one. It says, write a compound inequality that represents all numbers less than -3. If I just had to do that one, okay, less than -3, well, here's -3, and all the numbers that are less than that are headed that way, correct? That'd be the answer. But this one now says the word or, because we have 2, okay? So here's another one, or greater than or equal to 3. Well, greater than or equal to, I know the or equal to means this, and greater than heads that way. So that would be my answer to number 1. Now, do you notice how they're heading in different directions? I do. 100% of the time, OR graphs will head in different directions. One's heading to the left, one's heading to the right. You just have to worry about the dots and, you know, filled or open or closed or, you know, whatever. And then, of course, the number that it's attached to. Okay? So that's kind of our generic form. Also, like, again, smaller than the small number or bigger than the big number. So now we're going to write an inequality. What we're going to do is we're going to kind of put the stuff all together. It's going to look something like that. And so let's do all the numbers. This a number x is less than -4. Well, that seems pretty easy. X is less than negative 4. That's exactly right. I'm going to do the next one in red. It says, or greater than negative 1. Do you see x is greater than negative 1? I don't. A lot of times people might make a mistake and do this. Well, you got the right idea, but it's not the right format. In every OR problem, we're going to have two, let me write this in green. We're going to have two specific equations, okay? And they're going to be separated by the word OR. So it's going to be looking like this. X is less than negative 4, or x is greater than negative 1. That is my answer to my OR. Kind of just like two simple problems that we just did on the warm-up mixed together in one. Now if we have to graph this, let's just do that again. So if we're graphing this, pretty easy. There's two numbers here. There's a negative 4 right there, and there's a negative 1 right there. Those are the only two things that you have to write down on there. And then we should know, hey, ORs are heading just in opposite directions. X is less than negative 4, looks like that. Or x is greater than negative 1. It's heading that way. That, ladies and gentlemen, is my answer. Okay? Let's try number 2. I'm gonna erase this just so it doesn't look as messy and stuff. You can kind of see what I'm doing here. So number 2, it says a number x is less than or equal to 3. Let's just write that one down. X is less than or equal to 3. Now we're gonna write the word or, because that separates it. Now some people ask me, if I don't write the word or, is it going to be counted wrong? And the answer is yes, okay? I'm not a stickler about a lot of things, but this one that's kind of like a thing that we have to have. It's x is less than 3 or, and then now we'll do this one, greater than or equal to 7. Okay, x is greater than or equal to 7. That would be my final answer there. I'll draw the graph up above here just so I have a nice clean room there. Small number, big number, it's always going to be that way. And we should know, hey, it's going to be heading in opposite directions. So less than is that way, and greater than is this way. X is less than or equal to 3. Check. X is greater than or equal to 7. Check. Wrote them both down. We are done and moving on. Okay? Pause that, rewind that if you need to go slower. I'm trying to go fast just so we can get a bunch of stuff in here. All right? Example 2. Solve a compound inequality with OR. Well, what do you notice about this one versus our other ones? There's variables and there's like some algebra stuff we got to do. Okay? Well, that's no big deal. I'm going to maybe just write this a little bit larger so you can see it. X plus 7 less than 3, or 4x is bigger than or equal to 8. All right. If I just gave you this problem, you would probably be like, well, that's pretty easy. And it should be. We already did this one in the earlier sections, right? We want to get x all by itself. And so we just minus 7. And that gives me negative 4. Would I flip the signs around? No, because in this case, I just minused 7, right? I didn't multiply or divide by a negative number. And that would be the answer to that one, right? I mean, no big deal. No freaking out necessary. So if I had to graph that one, let's do that one down here. I'm going to keep room because I know I got another one coming, but negative 4 right there, right? It says x is less than that. Bloop. That would be that answer, right? Well, this one's just kind of a 2-for-1, these OR ones. We're going to have another simple problem over here. And we just want to solve that one, right? So same deal, I want to get x all by itself. 4 times x, well the opposite, or inverse operation of times is divide, so we just divide. We get 2. Sign stays the same. So then therefore, on my graph, it's going to look kind of the same, right? This one has a closed circle because of the or equal to, but x is bigger than or equal to 2. And that is my full graph right there, okay? So you look at the whole problem from the start, maybe it looks a little bit tricky because there's a whole bunch of numbers and x's and there's like 2 answers and stuff. But you just break it down as, hey, I got kind of this simple, easy problem, and I got that simple, easy problem, and it's not too difficult of a task. All right, let's look at a few more, and then we'll call this lesson good. Okay. Like I said, I wrote this down here. This is our cheat sheet kind of formula. X is smaller than the small number, or, gotta write that word, X is bigger than the big number. All right, let's just pick 2 more. We'll do this one, and then we'll do maybe the bottom one here next. So, first one, X plus 4 is less than -1, or the other one, 3x is bigger than 45. Well, let me just kind of draw a line there and do the math. I'm going to -4. And I get x is less than -5. No big deal. Or, do this one in green here. This one I'm going to solve. I'm going to divide by 3, and I get x is bigger than 15. That is solving the inequality. We have x all by itself, and we're good. Now we have to graph the inequality, so no big deal. Let's just toss that on a number line. We write our 2 important numbers down, which in this case, the small number is on the left, big number is on the right, just like it always will be. And then we have an open circle heading that way for that one. Or x is bigger than 15, so that's heading that way. And that one's done, and that one's done. There's our full final answer. Okay? And there's 3 of them. Which one should we do? Let's do number 6, and then we'll call it good. All right? Let's do this one. I'm gonna just rewrite it real big right here down here, so we have some room. -x, 9x minus 5, less than 13. Or, and let's do 2x minus 1 is bigger than or equal to 3. Okay, so let's say we had this one for our last problem, and extend the page. Perfect. Okay. Where's that number? There we go. All right, we want to solve and graph this. So first off, I'm going to just kind of ignore that entire second equation, and I'm just going to solve this first one. Okay. When we minus that out or get that out of the way, it's really pretty straightforward and easy. So now I'm going to have -9x. I'm going to keep following the sign down there. And then I have 18, right? Next up for us is going to be divide by that -9, divide by the -9. Then I'm going to get x, I'm going to get -2. And do I just kind of copy that down? Hopefully you're saying no or shaking your head no, right? Why? What did I do? Well, in this case, look at that. I divided by a negative number, so remember we have to flip the sign around. If we didn't, our graph would look kind of weird on that one. So that's that one. And then now I can't forget about my other half here, which is this guy over here. I want to get x all by itself. I'm going to add 1 to both sides. 2x, 4, that stuff, right? And then last step, divide by 2. And I'm going to get x is bigger than or equal to 2. So those, separated by the or, are my 2 answers. Is x smaller than the small number? Yes, it is in this case over here. Or x is bigger than the big number. It is right there as well. Okay? So let's graph our lines. -2, small number, big number. Looks like this one's an open circle heading to the left. Looks like this one right here is a closed circle headed to the right. Okay? And what do you know? Every single graph we graphed today looked exactly like that. So expect that, because those are the OR graphs, all right? We're going to call it a day for that one. So hopefully that makes a little bit of sense. You guys take care.
Mr. Big's math class. Mr. Big's math class.